Okay, y equals sine of x. Today we're going to talk about inverse trig functions. Before we can understand the inverses, let's make sure we can understand the other functions. You won't have to do anything on the front side on your test. On your test, you're going to do stuff on the back side. This is to try to get your brain in the mode and the understanding, okay, of why this matters, okay? You're going to need your calculator here in a little bit as well, or at least somebody you could share one. Domain is possible input numbers, okay? Possible x values. What kind of values can you plug in for sine? Can you plug in positive numbers? Negative numbers? 0? So your domain is from negative infinity to positive infinity. But the range, there's only specific values you can get out. Do you know the biggest value you can get out? 1. Smallest value? Negative 1. That's your range. Arc sine is if you were to go like y equals sine inverse of x. Or, the way we like to write as well is we call it arc sine. So that's a function. Arc sine is a function. Here's the problem. If you were to So, do you remember that when you found inverses back first semester, you would switch the x and the y values and you'd solve for the other, right? Also, if you looked at it graphically, the graph would be reflected over the line y equals x. That's what we did. And so don't draw all this, but if you reflected this graph around, you would get that. Now, what's the problem with that graph? It's not a function. Why is it not a function? It doesn't pass the vertical line test. So if you remember, anytime we came up with something that wasn't a function, we had to restrict its domain so that it was a function. And we restrict the domain to this segment here. So you could draw that. That's actually the graph of arc sine. It's kind of a, just a small segment of that little spiral thing. It goes from negative 1 to positive 1, and the height goes from pi over 2 down to negative pi over 2. Do you remember when we did that inverse stuff, that the range became the domain, and the domain became the range? So negative 1, positive 1 is the domain. But we had to restrict the domain to negative 1, positive 1. As you can see here, we don't want the range to go all the way through, otherwise it won't be a function. So the range is just going to be from negative pi over 2 to positive pi over 2. And if you think about that in terms of degrees, it can be from negative 90 degrees to positive 90 degrees. I'm going to get to why all this really matters for you and how you're going to use it. But that's the reasoning that we went through first semester. Okay? The cosine function, well, the cosine function looks something like that. Domain, negative infinity, positive infinity, range, bracket, negative 1, positive 1, bracket. Well, for this function, when you look at the inverse, it looks like this. So when we reflect it and restrict it, that's the shape you get. It still has a domain of negative 1, positive 1. What do you notice is different about the cosine, arc cosine, compared to arc sine? There's no negatives. It's above the x-axis the whole time. In fact, the range goes from 0 up to pi. So that value right there is at pi. And you can see that value is 0. We got 1, we got negative 1, yada yada. So that means you get degree outputs between 0 and 180 degrees. draw all this. Remember, tangent looks like that. Well, if we were to flip that, here's what you get. Is that a function? No. So what they do is they just go with the main one in the middle. So you can draw this. Domain is from negative infinity to positive infinity, and the range is from negative pi over 2 to positive pi over 2, or negative 90 degrees to positive 90 degrees. And they've got graphs for arc cosecant, arc secant, arc cotangent. When you get to calculus, we do a little bit of work with these functions. Really not that important right now, other than you know that you do use them. And we're going to use them all the time in section 7.5, which is after your test, which is the section I'm pulling off the test. Okay? So we can isolate it and just work on it, which I think will be your favorite section. You'll really enjoy it. It's good times. It's equations. It's solving equations. You're going to like it. Okay, take out your calculator. 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 Go, 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 go. Mode. Let's work in degrees. Watch what happens here, okay? Sine inverse. Sine inverse, type in -5. What do you get? Why? Yeah, you can't do an arc sine. You can't do a sine inverse of -5 because sine has to be between -1 and +1. That's the reason. You guys always said sine has to be between those values. So arc sine, when you plug it in, you have to have that. So all the time when you were doing your calculator, when you're going on your calculator going, oh, second sine, that's arc sine. You've been doing this for, the past month and not really knowing that that's the arc sine function. But how about this? Let's try plugging in a different number. Okay, we tried -5. How about -0.9? -64 degrees? Negative? Does that sound about right? Is that -64 degrees? Is that between -90 and +90? Yeah. You could try a different one, say sine inverse of -0.3. Get another one. It's between -90 and +90. Try a positive one, sine inverse of 0.5. You get 30. That's between there. You could do sine inverse of 0.9. 64. Think we could get above 90? Let's try. We'll go sine inverse of 0.999. Pretty close to 1, isn't it? Oh! Not there, is it? Sine inverse. Try again. 0.9999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999 Think I could get above 90? If you go sine inverse of 1.000000001. Let's see if we get something. Oh, your calculator is too stupid. Doesn't know how to do it. You know you can't get that, right? Our calculator does, the way it converts sine is it's estimating. Dumb calculator, don't do that. 1.0001, there we go. How about that? Error, there you go. See, can't do it. Can't do it. So, you kind of get the idea, but watch cosine. Cosine, try negative 0.9. Look at what you get. What's different about that compared to when we were doing sine? Sine gives you cosine gives you higher than 90, and it's not negative. Look, your cosine values, it's not your cosine. Arc cosine is not going to spit out any values that are negative. They're always going to be between 0 and 180, as you just saw there, 154 degrees. And tangent's like sine. It will spit out values between negative 90 and positive 90. Okay, so let's go to work here. Do you have that sheet of notes, the unit circle one that shows like the whole circle and the chart and everything? You want to take that out, and you want to have your calculator too. And we look at this sheet right here, and we'll do the arc sine piece by hand, and then we'll do it using our calculator. Okay. So look at your table. look at your table. Where is sine equal to 1/2 on your table? 30 or 150. Well, let's look. The arc sine has to produce values between -90 and +90. So which one's the correct answer? 30 degrees. Not that one. Now we want to do tangent inverse of -1. Look at your sheet. Where is tangent equal to -1? 135 and 315. Well, tangent inverse has to give you values between -90 and +90. Which one of these is between -90 and +90? Neither. Oh boy. Which angle is between -90 and +90 that's the same as one of these? Negative. Starts with F, rhymes with 40. That's the first part. Then there's a 5 after. 45, very good. -45 degrees. Think about it, everybody. 135 degrees is right here, right? And 315 is down there. So if you were to go from here all the way around, that would be 315. If you were to go this direction, that's -45 degrees. Those are in the same location, aren't they? So neither one of these is correct. It's -45. So that's why you can't simply look at your table. It doesn't have all the values for you. Okay? Sometimes you have to reason it out a little bit. Okay? How about cosine inverse of 3? Is cosine ever equal to 3? No. No solution. Or maybe you're happy you don't have a solution. I don't know. Okay, look at your sheet. Where is cosine equal to -√3/2? 150 and 210. Well, it says cosine inverse, arc cosine, has to be between 0 and 180. So which one's between 0 and 180? 150. So 150 is the correct answer. You understand why your calculator gives you the answers it does? It has to restrict it so that it can be a function. That's just the way it works. That's why your cosine answers are always positive. That's why you get some negative for tangent, okay? So let's do the problems you'll actually do on the test. This is your last content for your test on Wednesday. You guys have all day tomorrow to work. You'll have 20 minutes at the end of class today to work. I will have the key posted up. We'll have a wonderful day of learning together, and Emily's bringing treats. So it's a good day. Okay, it says, evaluate the expression by sketching a triangle. These are the type of questions you're going to have to do on a test, and here's my line in the sand. These are non-negotiable for me. I expect every single person in this class to get every one of these problems right. I totally get if you can't do, sine of theta plus secant plus tan over cosecant. I get if you can't do that on a test, okay? I know that that's hard. This you can do. Every single person can do this. So get the points you can get, okay? Here we go. We want to know what the sine of cosine inverse of 1/2 is. That looks kind of confusing, doesn't it? Think about it, people. When you do cosine inverse or sine inverse or tangent inverse, what does your calculator give you? What part of the triangle does it give you? It gives you an angle. It gives you a theta. So sine of cosine inverse, this piece right here, this cosine inverse of 1/2, just gives you theta. So we're actually trying to find out what sine of theta is. The piece of information that they give us is they say that cosine of theta happens to be equal to 1/2. And when you inverse it, you get theta. So what does it mean for cosine? In terms of a triangle, opposite, adjacent, hypotenuse, what does it mean if cosine is equal to 1/2? Give me your ratio, opposite, adjacent, hypotenuse. Cosine is? Adjacent over hypotenuse. So I know that 1/2 is the adjacent side divided by the hypotenuse. So we're going to call the adjacent side 1, and we'll call the hypotenuse 2. This is my triangle. Again, when you cosine inverse something, you're going to get that angle. Can we figure out what the sine of that angle is? How? Sine is equal to, in terms of opposite, adjacent, hypotenuse, what's sine? Opposite over hypotenuse. So I can figure out sine of this angle. All I have to do is figure out the opposite side. How do you figure out the opposite side? Pythagorean theorem. A squared plus b squared is equal to c squared. B squared is 3, so b is equal to? Root of 3. So again, this problem is simply asking, what is the sine of theta? Sine of theta is the opposite divided by the hypotenuse. What's opposite over hypotenuse? Yes. We'll do it one more time, see if you get it second time. I bet you get it second time. Yes. Opposite over hypotenuse. This problem's talking about a triangle. I'm just going to put in the pieces. It's asking me what sine inverse of 4/5 is. That means sine of theta is equal to 4/5. If it's asking what sine inverse of 4/5 is, that means we know sine of theta is 4/5. So let's just label our triangle. If sine of theta is 4/5, what side do I know? Opposite, adjacent, hypotenuse, what do I know? Opposite is 4. Hypotenuse is 5. What could be the other side? 3, because it's a 3, 4, 5 right triangle. So the question is saying, what is the cotangent of sine inverse of 4/5? When you sine inverse 4/5, what do you come up with? Every time you do an inverse on your calculator, you get an angle. This gives you an angle. That angle. So all we need to do is identify cotangent of theta in order to solve the problem. That's what this problem is really asking. What is cotangent of theta? What is cotangent as a ratio? Cosine over sine, or adjacent over opposite. Adjacent over opposite is 3/4. Did I ever solve for theta? Did I need to solve for theta? No. I don't need it. I construct the triangle and I understand the ratios appropriately. Secant of theta is 3/1. That's what it means to do secant inverse of 3. So if secant of theta is 3/1, what do I know? Which part of the triangle do I know? Opposite, adjacent, hypotenuse. Adjacent hypotenuse. Hypotenuse is 3. Adjacent is 1. If you inverse secant, you come up with an angle. So instead of tangent of secant inverse, I just have tangent of that angle. Can you figure out tangent of that angle? What is tangent? Opposite over adjacent. So we just have to find the opposite side. 1 squared plus b squared is equal to 3 squared. Or 1 plus b squared is equal to 9. B squared is equal to 8. B is equal to 2 roots of 2. So therefore, tangent of theta is equal to opposite over adjacent, 2 roots of 2. Somebody asked 4th hour, they said, Mr. Gens, I have no idea what's happening right here with the little arrow thing. They said, can we just cross it off and write down whatever tangent is? I said, well, I really wouldn't know if you were doing that at test. But I said, all you have to tell yourself is this just gives you theta. It just gives you an angle. Every time you press second sine or second cosine or second tangent, you come up with your desired angle. So just fill that in. Last example. Cosecant of cotangent inverse of 12/5. You know that cotangent of theta is equal to 12 over 5. What is cotangent in terms of opposite, adjacent, and hypotenuse? What's cotangent's ratio? Adjacent over hypotenuse. So you have adjacent is 12 and what? No. Adjacent over opposite. 12 over 5. There you go. So I know that much of a triangle. Well, if you do cotangent inverse of something, you come up with an angle. This angle, right there. What kind of triangle is this? A 5, 12, 13. Lucky 13. Go to Vegas. It's lucky 7, actually, isn't it? So, this problem is really asking not the cosecant of cotangent inverse, but rather the cosecant of theta. Cosecant is equal to hypotenuse over opposite. Yep, 13/5. So really, all you have to be able to do is construct your triangle and understand how to get those pieces. Yo. Oh yeah, wherever you put theta, that makes it opposite. Yep. There you go. That's it. You got 17 minutes today. You got 50 minutes tomorrow. I'm here before school. Not on Wednesday. I got meetings in the morning. Page 558, 35 to 52. No worksheets.